Today we're going to be talking about acceleration. So acceleration is defined at the rate of change of velocity. So it's how quickly an object's velocity is changing, so speeding up or slowing down. So the equation for this, and remember acceleration is a vector along with velocity, so it does have direction. And we'll kind of get more into direction, but sometimes direction is just determined based on positive or negative. So for this, acceleration equals v2, which is the final velocity, minus v1, which is the initial velocity, over t2, which is the ending time, minus t1, which is the starting time, okay? It can also be shown as acceleration is change in velocity over change in time, okay? So it can be kind of flip-flopped as well, where we have acceleration equals v2 minus v1 over change in time. Okay, so just depending on what kind of variables we are given in the given problem. Okay, so the units for this, if we're looking at the equation given, we have v2, which would be given in meters per second, minus v1, which would be given in meters per second, all over t2, which would be given in seconds, minus t1, which is given in seconds. So if we were to subtract these out, let's just say they're 1 or zeros or whatever it might be, okay, we would get meters per second on top divided by seconds. So if we were to kind of break this out into its different parts, it would be meters per second times 1 over seconds. And so what we end up with is meters per second squared, okay? So for the units of acceleration, it's going to be the distance unit over time squared, okay? So like we said, it's going to be meters per second squared, okay? It could also be kilometers per hour squared, just depending on what information we're given. Okay, so the acceleration is the rate of change of velocity. So how much is the velocity, meters per second, changing every second? So acceleration takes its direction from the change in velocity. So since the initial velocity and the final velocity could be in different directions, it's important to define which direction is the positive direction. Forward is generally the positive and backward is negative. So using a compass, typically our north and our east compass, these are going to be our positive directions, whereas the south and the west on the compass are going to be our negative directions. Okay, so you don't always need to use this convention. For some problems, it would be more logical to actually set south or west as to be the positive. Okay, so you really just have to determine what would best work for your problem given. Okay, so in order to solve an acceleration problem, you will need to know 3 of the values in order to solve for the 4th. Okay, if you don't have all that information, you're not going to be able to solve the problem. Okay, so things to look out for though are the key phrases from rest or to a stop. Okay, these are telling us the velocities without actually giving us numbers. Okay, so if we think about it, from rest means that it would start, meaning v1 would equal 0. Okay, to a stop, it means that our stopping velocity, or our v2, would equal 0. Okay, so it's important to look for those. If you only have 2 out of the 3 numbers, look for phrases such as these. It might be that your either starting or ending velocity is 0. Okay, so for example 1, a horse begins a race from rest with an acceleration. So we have an acceleration of 2.2 meters per second squared north. What is the horse's velocity after 5.8 seconds? Okay, an important thing to note, so we only have two things highlighted here. Okay, we have acceleration, we have a final velocity, we don't know what, or we have the time and we have the acceleration. We don't have either one of the velocities, okay? But here, from rest, this is telling us that V1, because this is the beginning of the race, is 0 meters per second. Okay, so writing out all of our units, we have V1 equals 0 meters per second. We don't know what V2 is. That's what we're trying to solve. Our time is 5.8 seconds. And then our acceleration, which is given to us, is, put all my hats on my velocities, 2.2 meters per second squared. Okay, the nice thing is that our units all match. We're in meters and in seconds for all of our different measurements. Okay, so our equation is A equals V2 minus V1 all over delta T. So if we rearrange this equation so that it's solved for V2, it would look like this. We would have acceleration times delta T plus V1. Okay, so this is equal to V2. Okay, so now we're solved for velocity, the ending velocity. Okay, so plugging in the numbers, our acceleration is 2.2 times our time, which is 5.8, plus our velocity, our starting velocity, which in this case is 0, equals our ending velocity. Okay, so multiply and then add, and we get 12.76 meters per second, and they were headed north, which I forgot to add that to our acceleration. Okay, and then this is our final velocity after the 5.8 seconds. All right, example number 2. A hockey puck with an initial velocity, so our initial velocity is 65 kilometers per hour west, ricochets off the board. After 0.76 seconds in contact with the boards, its final velocity is 47 kilometers per hour east. Determine the acceleration of the puck. Okay, in this case, we are going to let east be the positive direction. Okay, so we're just going to establish that now before we kind of write down all of the different values, okay? So we have V1 is 65 kilometers per hour west. Okay, so another way to write this, because we're letting east be positive, would be negative 65 kilometers per hour east. Okay, just so that we're in the same. Our final velocity is 47 kilometers per hour east. Okay, it's already in the positive direction, or it's already in east, so it's going to stay positive. And then our time is 0.76 seconds. Okay, and we don't know what acceleration is. Alright, so we do have an issue already because our time is in seconds, but then our velocities are given in kilometers per hour. So we need to change our velocities to meters per second in order to have the same units throughout the problem. Okay, so let's go ahead and change our kilometers to meters first. So there's 1,000 meters in 1 kilometer. And then there are, in 1 hour, there's 3,600 seconds. And we should get negative 1805 meters per second, and then it would be east. Okay, really it's west because it's negative east, which would be the opposite direction, west, but we've changed it. Okay, and then for this one, changing kilometers to meters, 1,000 meters in 1 kilometer, and then our hour into seconds, we get 13.05, repeating, meters per second east. Okay, so now we have all of our variables. We can plug it into the equation of A equals V2 minus V1 all over T. Okay, so we got 13.05, which is our V2, minus negative 18.05. Okay, make sure you don't forget that negative, divided by our total time, which is 0.76 seconds. Okay, so we get the acceleration of 40.9, and it's going to be in meters per second squared. Okay, so it's moving in the positive direction, which means it's going east. So it's accelerating or speeding up towards the east.